So water is actually a pretty remarkable molecule. It's got a low molar mass, but it's a liquid instead of a gas at room temperature. And it's a good thing, because if it was a gas, we'd have some problems. So here we have a graph of the boiling point versus the period of X in an H2X molecule. So we've got H2TE, H2SE, H2S, and H2O. And if we look at this graph without considering where water is, the one with oxygen, we see that there's a trend here, right? So if we drew a line, we'd expect something like that. We would expect water, oxygen with hydrogen, to follow a similar trend and have a boiling point down here somewhere, about minus 100. But it doesn't. Its boiling point is way up here. And the reason for that is because of hydrogen bonding, that strong intermolecular force. H2S, H2SE, H2TE, those are all polar molecules. You draw the Lewis structures, the central atom has lone pairs. They are polar. But can they do hydrogen bonding? ET phone home. Nope. Only oxygen. We don't have nitrogen or fluorine in there. This huge difference is due to hydrogen bonding. Because water is very polar, it allows it to be an excellent solvent. It will dissolve many ionic compounds and many polar compounds. Water is the main solvent in living organisms. Most of your body has water as the solvent for all the things that are dissolved in it. We can't have life without water. And they go looking in outer space for life on other planets. They're looking for water. If there's no water, there will be no life. If they find water or evidence of water, then possibly you could look further. Nobody's found anything yet. Personally, I don't think they ever will, but they enjoy looking. The way water freezes is also unusual. Most solids are more dense than their liquids because they compress just a smidge as they freeze. Water's different. Water actually expands as it freezes. This makes ice less dense than water. That's why ice floats in liquid water. So this is a good thing. I grew up in Minnesota and Iowa, and there the lakes freeze in the winter. If the ice was more dense, it would sink to the bottom as it froze, and all the lakes would freeze solid, and there would be no awesome fishing in Minnesota. But the ice freezes and stays on the top of the water and effectively insulates the rest of the lake from freezing. This can also cause things that may be interpreted as negative. If the power goes out in your house and you're not home and the water pipes freeze, freezing water is strong enough to break metal pipes. Have you ever put a water bottle in the freezer or a can of soda in the freezer and forgotten about it? You ever done that? What happens? It breaks. Because as the water freezes, it expands, and it's actually quite powerful. It will break the container that it's in. So if you want to freeze your water bottle, make sure that you take some of the water out and leave some space in there for the ice to expand. We've had lots of issues with refrigerators. I think one of the common issues people have is that if you get the temperature in the refrigerator a little too cold, then the lettuce freezes, right? Now, some things, if they freeze, the meat freezes, we'll thaw it out, it's fine. What happens when lettuce freezes? It wilts. It's nasty, right? Or if you've got hostas in your garden and we get a freeze, and you go out there and there's like limp lettuce, right? They're just like, we give up. What's going on there? Well, in the cells of that living tissue is water. When it freezes, it expands and it breaks the cell walls, and that's what's causing the lettuce to go all limp on you. So some foods do not freeze well. Others freeze fine. When you freeze fruits and vegetables commercially, what they do is a flash freezing process that freezes it very quickly. And in that process, the molecules do not have enough time to rearrange themselves into this open structure, and so there's less damage to the food than if you freeze it yourself.